At our textbook activity 10A question 3, we've got a cart that's free to roll on wheels, and it's got a string connecting it over a pulley to a mass of 4 kilogram, and we need to ask a few questions about it. Part A, what is the force of gravity on the object in Newton? So we've got this object here, and there's a force of gravity down, and we recall our formula. The force of gravity is equal to mg. So mass of 4 kilograms times g. We're given g, acceleration due to gravity, strength of Earth's gravitation field at this point is 10 meters per second squared. So weight, force of gravity equals mg equals 4 times 10 equals 40, and our units, it's force, so our units are Newton. Part A, question A. Part B, what's the combined mass of the cart and object? We've got the mass and the string. We'll consider the string of negligible mass, 6 kilograms, so the overall mass, the total mass, is equal to 10 kilograms. C, what is the acceleration of the cart and the 4 kilogram object? Now these are tied together by the string. As the mass is pulled down, the cart's pulled, and because the string's not stretching, they're going to have the same acceleration and the same velocity at each point. So what's the acceleration of the cart? We use our equation F equals ma. The force we've identified as 10 Newton. The mass, combined mass, is 10 kilogram. We need to find the acceleration. Rearrange. Acceleration is force divided by mass is equal to 40 divided by 10 equals 4. And again, our units for acceleration, meters per second squared. And let's look. We're given that the g is 10, two significant figures. We're given the mass is two significant figures, so therefore we're going to do our acceleration as 4.0 meters per second squared, two significant figures. D, what is the speed of the cart after it's moved forward 50 centimeters from rest? And so let's use our guess. What is our given? We're given the initial velocity is 0. We're given the acceleration. We've calculated the acceleration. We're given that the trolley moves 0.5 meters, and it says 50 centimeters. Make sure we convert that to meters, 0.5 meters. Our unknowns is our final velocity. So what's an equation which ties just those together? Vf squared is equal to V initial squared plus 2AD. Substitute and solve, and we get final velocity is equal to 2.0 meters per second. And again, two significant figures for that. Question E, what is the tension in the light cord? Hint, the tension is the force that acts to accelerate the cart. What is the tension in this string here? We've got this cart here, and we see that it's got an acceleration of, what was our acceleration? 4 meters per second squared. And we've got a mass of 6 kilograms. What is the force accelerating it at 4 meters per second squared towards the left? And what's providing the force? Well, the only force we've got really is the tension in the string. So the tension in the string, this tension here, this tension force in the string, has got to be the force which is accelerating this cart. So let's use our simple equation here. What is the force which is accelerating this. Remember our equation here, Newton's second law, F equals ma. The force is equal to the mass, 6, times acceleration is 4. Force is equal to 24, and force is in Newton. So the force pulling this cart to the left, provided by the string, the tension force in the string has got to be 24 Newton. So that's question 3 from our activity 10A.